Hi everyone, we are back with another paper today. Today we're solving this math paper. This is math paper 5, Probability and Statistics 1 S1. It's 9709, paper 5.3 from the May June 2024 series, and the time is 1 hour 15 minutes. So this paper is actually a request from one of my patrons, Mohan. So if you guys like to be featured or if you want your papers to be solved in my next videos, please consider supporting me on Patreon. Currently, we have 3 tiers. The first tier is just for general support regarding question papers and exams, study techniques. And then we have the most popular tier, the one for solved papers, notes, and requests, where you get access to all my notes for physics, chem, math, and bio, as well as all my solved papers for science, paper 1, 2, 4, and 5 on OneNote. It will be shared to you guys via OneDrive, as well as math P1, P3, M1, and S1 for papers solved from 2002 to 2024, and mostly papers solved 2016 onwards because the syllabus was much more, much different before those years. But yeah, there are papers from 2010 onwards as well. So there's that. As well as you get access to ad-free videos as well as requests for question paper solving in my next YouTube videos. And for the highest tier, the ultimate learning experience, currently we don't have any patrons here. It's much more common or popular during the May June series, where you get access to one-on-one video meetings with me via Google Meet once or twice a month, including all the perks in the previous tiers, as well as priority for question paper solving requests. So if you're interested, if you like my videos, if you need more support during your exams, please feel free to support me here. And if Patreon payments are not available in your country, please feel free to email me. We can work through that in some other way. Anyway, let's start with the paper. And yeah, let's take a look at the threshold first, shall we? So here's the threshold for this paper. We are doing paper 5.3, component 5.3. Out of 50, this is the threshold. So as you guys can see, A was at 44, which is a pretty high mark. It's a pretty high mark. Where's the booklet? Okay, wait 1 sec. There you go. Okay. So for paper 5.3, out of 50, A was at 44, B was at 39, C was at 32, D was at 25, and E was at 18. So A stars, you can look at the mark difference, or if we just consider half of it, it should be at 47 or 48. So since the threshold is so high, that usually indicates that this paper was much easier compared to the other ones, because if you take a look at the threshold for the other ones, look, 36 was A for paper 5.2 and 37 was A for paper 5.1. So what does that indicate? These two papers were much harder than component 5.3. Okay, so that's the general idea. Anyway, I don't think we should waste any more time. Let's start the paper. We should take about 40 to 50 minutes. Back in the day, just before the exams, I was finishing a paper in 30 minutes. So if you want full marks, I actually got 99 in my math exam. It was the highest in the country at that time. I got full marks in all components except mechanics. In M1, I got 49 out of 50. I don't know why. Maybe it was due to significant figures or something. I'm not really sure. But yeah, be careful. So we have to give all non-exact numerical answers correct to 3SF or 1 dp for angles and degrees. Let's start. So the numbers on the faces of a fair six-sided dice are 1, 2, 2, 3, 3, 3. The random variable x is the total score when the dice is rolled twice. Okay, so for this, what do we need? We actually need a table like this. So 1, 2, 2, 3, 3, 3. 1, 2, 2, 3, 3, 3. So basically, we are going to total the scores, or basically the sum, right? Okay. So we have 2, 3, 3, 4, 4, 4, then 3, 4, 4, 5, 5, 5. Also 3, 4, 4, 5, 5, 5. And here we're gonna get the same ones, 4, 5, 5, 6, 6, 6. So it's gonna be the same down here. Yeah, okay, that's good. So let's draw the table. It's a probability that x will be equal to x. Okay, so what are the probabilities? What are the things that we can get? The scores are 2, we can get 3, we can also get 4, we can get 5, and we can get 6. So these are it. Okay. So now what? We have to write down the probabilities, okay? So how many times did we get 2? Just once. So that's 1 out of 36 times. How many times did we get 3? 1, 2, 3, 4 times. 4 out of 36. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. 10 out of 36. And for 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36, 1 by 3. And for 6, we got it 9 times. 9 out of 36 times. Okay. That's fine. That's good. So yeah, you can simplify it. It's not mandatory, okay? So they wrote 5 correct probabilities. May not be in the table. Yeah, that's fine. That's fine. Okay, anything works except unsimplified. It's fine. You could keep this as 1 by 9, then 5 by 9, 6 by 9, which is 2 by 3. Anything works, honestly. Sorry, 1 by 3, yeah? And 1 by 4. So alternates include, you could write this as 1 by 9, this as 5 by 18, sorry, 5 by 18, then 1 by 3 or 1 by 9. Anything works, okay? Find the value of variance. So how to find out variance? We know that variance is basically summation of x square f minus expectation square, right? X square p here. So let's find out the expectation first. What will the expectation be? It's basically 2 times 1 by 36 plus 3 times 4 by 36 plus 4 times 10 by 36 plus 5 times 12 by 36 plus 6 times 9 by 36. Okay, so what are we getting as our final answer? It is basically 14 by 3. $40 by 36, 60 by 36, 54 by 36. Okay, so we are getting 14 by 3. So now let's move on to variance. So variance will be actually summation of x square p. Okay, summation of x square p. What does that mean? 2 square into 1 by 36, 3 square into 4 by 36, 4 square into 10 by 36, 5 square into 12 by 36, plus 6 square into 9 by 36. So if you do the working, you are actually going to get, oh, this thing minus expectation whole square, of course. So you are actually going to get 824 by 36 if you complete the working. And for this, 14 by 3 whole square is actually 196 by 9. So overall, the final answer is 10 by 9. Okay, that's great. That is our answer. Find the probability that x is even given that x is greater than 3. Okay, so this is conditional probability. You guys have to find out the condition. The condition is that x is greater than 3. So this is how you write it. Okay, so x is greater than 3. This is the condition, and we have to find out that it's even. So let's find out the probability that x is greater than 3. So 3 is not included. So greater than 3 includes these 3, 4, 5, 6, 10 by 36, 12 by 36, and 9 by 36. Fine. And even. So which one is even? 4 and 6. So that's 10 by 36 and 9 by 36. We can't include 5 because it's an odd number, yeah? So let's do this. 10 by 36 plus 9 by, oh yeah, we can just write 19. And below it's going to be 22 plus 9, which is 31. So our final answer is 19 by 31, yeah? Okay, great. Question 2. In a certain country, the heights of the adult population are normally distributed with mean 1.64 meters and standard deviation 0.25 meters. Do you guys like my new mic, by the way? It's actually a way better mic. I used to have a gaming headphone before, but now it's an actual mic. I can actually do ASMR using this. I actually always wanted to be a streamer. I never actually got the chance. But this is a streaming setup, essentially. So if I want, I can stream games. I recently played Black Myth Wukong, by the way. I platinumed it recently. Just today, actually. PS4, in the PS5. Such an amazing game. Can't wait for the DLC. Anyway, let's start. So x is normally distributed with mean 1.64 and standard deviation 0.25. Okay. So probably that someone will have a height greater than 1.93. So what's the technique? We need to standardize it, yeah? So it needs to be converted to less than 1 minus p x is less than 1.93. Now let's standardize it. 1 minus p, convert all greater than's to less than's because less than is only applicable for the table that we have. So now to standardize, how? The value minus the mean divided by the standard deviation, which is 0.25, yeah? So 1.93 minus 1.64 divided by 0.25, which gives us 1.16, okay? 1 minus p, that is less than 1.16. Okay. Now we move on to the table. What is this? This AI? Okay, whatever. Going to try that out. So I'll just erase of this. So I'm looking for 1.16, yeah? So 1.1 and 6. 1, 2, 3, 4, 5, 6. Here you go. 1.16 is 0.8770, 0.8770. So the answer is 0.123. Fine. That's good. Next. In another country, the heights of the adult population are also normally distributed. 33% of the adult population have heights less than 1.56. 25% of the adult population have height greater than 1.86. Find the mean and standard deviation. Fine. So in another population, so y is also normally distributed with mean mu and standard deviation sigma square. So p y is less than 1.56 is 33%, which is 0.33. At the same time, py is greater than 1.86 is 0.25. So let's do this. Pz is less than 1.56 minus mu by sigma is 0.33, and here 1 minus py is less than 1.86 is 0.25, or py is less than 1.86 is 0.75. Fine. Next, standardize it. Pz is less than 1.86 minus mu by sigma is 0.75. Now here's the tricky part. Okay, so what does the probability of 33% mean in the standard normal distribution? This is 50%. So to be 33%, you have to be behind the y-axis. Okay, so that means this is in fact a negative value. This thing inside is a negative value. So look, how do you convert negative values to positive? What do you need to do? You take the symmetry. So that means this part will actually be equal to this part. So it's the same as 1 minus p x is less than 4. Because if this was minus 4 and if this was plus 4, if you did the whole thing, right? The whole thing minus this small section over here. This is what I mean. If you did the whole thing, which is 1, minus this small section over here. Sorry, if you did the whole thing. So sorry. Minus this section over here, less than 4, you would be getting this small portion. And this small portion is in fact equal to this part over here. Okay. So that's the logic behind converting negative to 1 minus positive value. So I'm going to do that. Okay, I'm going to do that. So 1 minus p z is less than minus, sorry, my TV just turned on, 1.56 minus mu by sigma. Okay, 0.67. So p z is less than, fine. Now we go back to the table and I'm looking for 0.67 and 0.75. But this is the inverse, right? 0.67 and 0.75. Okay, so maybe my videos are not the best for people who are starting out with this one. This is like an end game video, okay? I'm just solving papers, assuming that you have finished the syllabus at least once. But I am actually planning to launch a course at the end of the year or the start of next year for statistics. There will be a few free classes online, but the whole course will be paid. It will be like $200 or something for like 1 or 2 year access, which you can buy through Patreon or something. Let's see, I have plans. So if you guys are interested, please do comment below. And if you guys are from Bangladesh, I do have a course recorded already, which is available for sale. You can buy that if you want. But I do plan to launch an international one for everyone, which will have all the chapters explained with question paper solving and all sorts of variations. So if you're interested, please do comment below. Let me know. Then I'll work on that sooner, okay? So what are we looking for? 0.67 and 0.75, okay. 0.67, I have that over here. So that is 0.44. Fine. And 0.75. 0.75, I have that over here. 0.674. 0.674. Okay, so 1.86 minus mu by sigma is this, and here minus, fine, okay. Minus 0.44 sigma. Okay, now we can solve them. Let's solve them by simultaneous equations. So I'm gonna change the sign. Okay, we can get rid of these. 1.56 minus 1.86 is minus 0.3. Minus 0.44 minus 0.674 is minus 1.114 sigma. 0.3 by answer. So sigma to 3SF is 0.269. That is what I'm getting. I'll check the mark scheme though. Yeah, okay. So for mu, I'm going to input it here. 1.86 minus mu is equal to 0.674 into 0.269. So after working, mu is 1.79 to 3SF. So that's one answer. And this is the other one. So mu should be 1.68. Maybe I made an error here. Wait. 0.3 divided by 1.114. Yeah, it's 1.68. Sorry, I made an error in the calculator working. Okay, so yeah, these are our answers. Moving on to question number 3. Box A contains 6 green balls and 3 yellow balls. Box B contains 4 green balls and X yellow balls. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. Draw a tree diagram to represent this information, showing the probability on each of the branches. Fine. So at first we are taking from box A. So we can either take a green ball or a yellow ball. The probability of taking a green ball is 6 out of 9 and taking a yellow ball is actually 3 out of 9. Fine. And then we place it into a box B. So box B contains 4 green and X yellow. So if you add this green ball to box B, how many do you have in total now? 5, right? So it's actually 5 divided by what's the total? 5 plus X. And what about yellow? You did not add a yellow ball, so it's still X divided by 5 plus X still. Okay. And here, what about this? You still have 4 green balls, but it changed to X plus 1 now. So X plus 1 plus 4, which is still 5 plus X. The total will be 5 plus X. This is for green. But for yellow, what happened is, since you added another ball, you have X plus 1 yellow balls in the second box, box B. And in total, you still have 5 plus X balls. So this is the general idea. In box B, the total number of balls will actually increase by 1. So you had 4 plus X balls initially, but you add another ball, so the total number of balls will actually be 5 plus X in all the scenarios respectively. But the numerator will differ according to the ball that you've taken. That's the general idea, yeah? Okay? But the denominator will be the same. Okay. Fine. The probability that both the balls chosen are the same color is 8 by 15. So P, same color, is 8 by 15. What does that mean? Green, green, yellow, yellow. So green, green, that is 6 by 9 into 5 by 5 plus X. 6 by 9 into 5 divided by 5 plus X plus 3 by 9 into X plus 1 by 5 by X. Okay, fine. So let's do this. 30 by 45 plus 9x. 3x plus 3 divided by this. Or 30 plus 3x plus 3. Fine. Cross multiplication. Let's see. 5. X is 5. Okay. We got it. We got him, boys. Okay, let's move on. How many questions do we have in this paper? Oh, 3 more questions left. Okay, we'll be done in 20 minutes. Draw back to back stem and leaf diagram. Okay, so penguins and dolphins. Time taken by. Oh, these are actually members of 2 swimming clubs. Alright, fine. So penguins and dolphins. So we have to look for the least value, which is 35, and highest value, which is 72. So it starts from 3, goes up to 7. Fine. Now for penguins, 35, 39, 42, 44, 45, 45, 48, 50, 56, 58, 59, 61, 66, 68, and 72. And here we have 36, we have 41, 43, 48, 49, 49. Then we have 50, 51, 54, 56, 56, 60, 61, 64, and 71 over here. Okay. So we need to give the legend or the key. For example, we can use this one over here, 2, 4, 1. What does that mean? It actually means the times are in seconds. Okay. So 42 seconds for penguins and 41 seconds for dolphins. Fine, looks good. Next, on the same diagram, draw a box and whisker plot to represent the time for the dolphins. Okay, let's go. So for a box and whisker plot, we need 5 values, okay? Least value, Q1, Q2, Q3, highest value. So least value is 36, no doubt. Highest value is 71. And for median, how many numbers do we have? 15. So for 15 numbers, how do you go about it? It's the median will be 15 plus 1 since it's odd. 15 plus 1 by 2. So 16 by 2, which is the 8th value. The 8th value is the median or Q2. And 7 values on the left, 7 values on the right. So since 7 is an odd number, 7 plus 1 divided by 2, which is 8 by 2, which is the 4th value. So the 4th value will be Q1, the 8th value will be Q2, and after the 8th value, the 4th value again will be Q3. So 1, 2, 3, 4, 5, 6, 7. So I'm dividing it here. This is Q2, 51. And since there are 7 numbers on the left hand side, the middle value is the 4th value, which is 48, Q1. And then 1, 2, 3, 4, 60. There you go. So I need these values to actually plot this for dolphins. Okay. I really like penguins, by the way, as well as dolphins. They're really nice. Okay. So let's go. Just draw it like them. 48, yeah. One, two, three, four. And then 51, 60. Bro, why is it so hard? Okay, next at 36. And 71. There you go. So I try to copy it like them, like exactly how they did it, but yeah, this is the general idea. Okay. Instead, one difference between the distributions of the times for the penguins and the dolphins. So, in general, as you can see, the median time for penguins is 50, but the median time for dolphins is 51 seconds. So, what does that mean? Penguins have a faster time in general. And if you think about the spread of the data, look at the spread. For dolphins, it's 71 minus 36, which is 35. That's the spread. And for penguins, it's 72 here, and it's 35 here. 72 minus 35, that is 37. That's the spread of the data. So yeah, dolphins have more consistent times, or it's less spread out. Okay, so those are the possible answers. So you can either say that dolphins have more consistent times than penguins, or another explanation is that since the median time for penguins is lower, penguins are faster, or you can say that penguins have faster times than dolphins. Yeah, sounds good. Okay, moving on to question number 5. We just have 2 questions left. We will be done soon. Salah decides to attempt the crossword puzzle in his newspaper each day. The probability that he will complete the puzzle on any given day is 0.65 independent of the other days. Find the probability that Salah completes the puzzle for the first time. If you see text like this for the first time, it's a geometric distribution, no doubt. X is geometrically distributed. Okay. And the probability of success is 0.65. First time on the 5th day. So Px is equal to 5. What does that mean? He has failed 4 times. So success on the 5th day and failure on the first 4 days. Okay. So let's write this down. That is 9.75 into 10 to the minus 3, or 0.00975. Typically in statistics, we don't give standard form answers. That's for physics or chemistry. Find the probability that Salah completes the puzzle for the second time on the 5th day. By the way, guys, if you do like my content, please do drop a like and remember to subscribe to the channel. It actually really helps a lot with the subscription and the ad revenue, and gives me more motivation to make videos for you guys. So yeah, please do drop that like button and subscribe to the channel, please. Thank you. And thank you guys for all the continuous support throughout the years. I wouldn't be able to be here without you guys. And hopefully I can support you a lot for a long time, as well as your juniors in the future. I plan to continue this until I reach 100k. After that I might stop. So maybe a few more years. Let's see how long it takes. Find the probability that Salah completes the puzzle for the second time on the 5th day. Okay, this is a bit complicated, but I've seen sums like this before. So first day, second day, third day, fourth day, fifth day. So okay, we get a success on the fifth day. Success. Now here's the thing. The first success could be on any day. Okay, it's like this. Or it could be failure, success, failure, failure, success, or failure, failure, success, failure, success, or failure, 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 and success 2 times consecutively. Okay, so what does that mean? This 0.65 is fixed, but this 0.65 is variable. Okay, so what does that mean? 1.65 is fixed, and these four, it's basically permutation combination, right? Like a b b b. What does that mean? 4 factorial divided by 3 factorial, right? What does that mean? Just four ways of arranging this, 4 possible ways. 1 2 3 4. So 0.65 into 0.65 into 0.35 cube into 4 factorial by 3 factorial, or simply 0.65 whole square, because there are 2 successes, 0.35 cube times 4. This is what they wrote in the mark scheme, but without explanation. I just explained it to you guys. That's why I'm here. I got you guys. That is the answer. Find the probability that Salah completes the puzzle fewer than 5 times in a week. Okay. So this is no more the geometric distribution, but rather, since you have a fixed number of days, it is actually a binomial distribution now. So y is binomial distributed, the probability of success is 0.65, and the number of observations is 7. So p y is less than 5. Okay, so that is p y is equal to 0 1 2 3 4, or you could write this as 1 minus p y is equal to 5 6 7. This is the easiest route, so let's do that. So 7c5 7c6. God damn it. This is our final answer, 0.468. Hopefully I could clear it for you guys. Okay, now is this suitable approximation to find the probability that Salah completes the puzzle more than 50 times in a period of 84 days? Okay, so same distribution with probability same, but suppose, so use another letter. Like maybe, L is binomial distributed in a period of 84 days, and the probability, oh sorry, I wrote something wrong here. It's NP, right? So NP, probability comes later, my bad. Okay, so we are going to convert it to a normal distribution first. Let's call it K. How? We are going to find out mean, which is NP, 84 times 0.65, 54.6, and variance, which is NPQ, which is NP times failure. So mu and sigma square, mu and variance. Okay. So now let's do the approximation, yeah. So 50 times. More than 50 times. More than 50. 50 is not included. So it's from here. So we have to take 50.5. So we are adding probability that L is greater than 50, but it's too hard to apply the binomial distribution. It's going to be too complicated. So we are going to convert it to a normal distribution. How? So pk is going to be greater than 50.5. We just applied the continuity correction of 0.5. That is what you have to do in all sorts of sums with approximation, yeah. Okay, now we standardize. How? 1 minus pk is less than 50.5. 1 minus pz is less than 50.5 minus 54.6 divided by standard deviation, which is root 19.11. Always 3 dp, yeah. 938. So let's look for 0.938 on the table. Zero 0.93 20. 0.8238 plus 20, which is 0.8258. 0.8258. Now we have to round this off to 3SF since it's non-exact. 0.826 is our final answer, yeah. So hopefully that makes sense for you guys. They did keep it to 4 dp for some reason. They wrote 0.9379 here instead of 0.98, but you should just keep it to 3 SF. That is totally fine. That is 100% okay. There is no issue with that, okay? If you do it like this, you're gonna get full marks, okay? Last sum now. Permutations. I really like doing permutations. Let's go. How many arrangements are there of the 9-letter word recorders? Okay, let's write this down first. Like this. R, R, R. Double E. CODs, cods. Fine. So in total there are 9 letters, 9 factorial, divide by the repetitions. 9 factorial. Why do I always lose the factorial in this calculator? It's so annoying. Where is it? I can't find. I found it. That is 30240. Fine. How many different arrangements are there of the 9 letters in the word recorders in which there's an E at the beginning, E at the end, and the 3 R's are not all together? Good sum. Okay. So E at the beginning and E at the end, and since the 3 R's are not together, we are going to apply the arrow method. So I'm going to exclude them for now. So I'm going to be using these 6 letters, okay? Always remember this technique. 1, 2, 3, 4, 5, 6. Okay. So E's are at the ends. I'm going to be ignoring the R's for now. Chords will be in the center, okay? So for chords, we have 4 factorials since all of them are unique. And the R's cannot be, oh, they're not all together. They did not say not next to each other. So what does this mean? If it was said that they're not next to each other, then I would use this arrow method over here, okay? But here, if they said that they are not next to each other, I would progress in this fashion. However, since they said that they are not all together, what does this specifically mean? That the three R's cannot be together side by side. That's what it means. Okay. So what I have to do is I have to find the total number of arrangements and then subtract those particular arrangements where the R's are together, or else it's gonna be too complicated. Because I have to do it two ways then. Like I have to find out the ways in which the R's are in a pair, right? And when the R's are not next to each other, which is a bit complicated. Okay, so this is how I'm gonna approach the sum. Not all together. So let's make them together first, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. So E's are at the ends. Suppose the R's are together. 1, 2, 3 as one unit. And then chords. So how many units do we have? The E's are fixed. Okay. So how many units do we have? 1, 3 R's are 1 unit and chords 5 units. So that is 5 factorial. That's it. Okay, because the R's are repeats, so we don't have to do anything. It gets cancelled out. Okay. Next. Now, we are going to find out all possible arrangements. Okay. How? 1, 2, 3, 4, 5, 6, 7, 8, 9. So R chords. So how many letters do we have in the center? We have 7. So that is 7 factorial. Divided by the repetitions, 3 factorial. Okay. So these are total arrangements where we don't give language, where we don't care about the R's being in a pair, alone, separate, or all three together. Okay. So now we are going to find out the answer where the R's are not all together, which is 7 factorial by 3 factorial minus 5 factorial. Which is 720. Okay, great. Let's go to the last one, I guess. Final sum for the day. The 9 letters of the word recorders are divided at random into 2 groups. Okay, so there was a sum like this. Imagine 2022 variant 52, like crocodile. There was that word. So find the probability that the 3 R's are in the same group. Group of 9 letters. Group of 5 and 4. 1, 2, 3, 4, 5. And here we have 1, 2, 3, 4. Okay. So since the R's are repeats, that's the hard part, okay? That's the hard part. So, and there's also the E, which is also a repeat. So I'm going to show this in multiple methods. So there's one way like this, like all the R's and both E's are in this group. Okay. Then what else? Wait, let me just do this. And then what can we do? Like 3 R's are in this group with 1 E. 3 R's are in this group without any E's. Okay. And now we are going to consider the R's in the other group. Like we can have 3 R's over here along with 1 E, or we can just have 3 R's over here. Why am I doing this? Because I am looking for my condition, which is having, as you can see, all 3 R's in the same group. That is why I kept all 3 R's together all the time. But why am I making special consideration for the E? Because it's the only letter which repeats in recorders except R. We can ignore R because they're in the same group. But you cannot ignore E because you can treat chords, CODS the same because it doesn't repeat. But you cannot treat E the same because it repeats once, okay? That's why you need to make a special consideration for the group of 5 and for the group of 4 over here. Okay, so for this one, codes 4 letters, 4 blanks, so that's basically 4C4. What about here? The E will be over here. Yeah, the E will be over here. So it is essentially, we are going to pick one out of 4 letters codes. One will go here, 4C1. Okay, one letter just goes there. Okay, let me show you something first. So the E has to be here, right? Similarly, the E's have to be here, and here one E has to be over here, and here both the E's have to be here. Okay, that's the general idea.